So again, law of sines, we're given an angle and two sides. And because I don't know another angle, this is going to be harder to draw. So I can just kind of make a guess as to what the triangle is going to look like based on this. And with good geometry software, you can actually draw it out perfectly. So I'm going to make a baseline down here to start with, and then an angle of 106. So let's see. 90 degrees is straight up and down. So 106 is probably off this way-ish, maybe there. So that's my guess at 106 degrees. And again, without a protractor, it's just a guess off of 90. So I think that's A equals 106. Side A is going to be opposite over here. And then usually we go A, angle B, angle C would be up here. So if angle B is over here, side B is usually over here. But the direction you go around doesn't really matter. But I'm going to put side B over here. So let's say my 15 is going to be over here. So B equals 15. And let's kind of just mark off, maybe that's about 10 right there. That would be another 10 right there. So 15 should be right here. So that's going to be the point I want. So I usually try to rough draw these if possible. And then if that's 15, draw 26. So let's see, side A is going to have to be opposite. So then I need to make from here, if this length is 15 here, I need to make a 26 come down here. So let's see, that would be about 10, 20, 26 is going to be somewhere over here. All right, so if I say this is 15, then that's around where 26 is going to be. And sorry, my picture's a little messy there. So this over here, I think, is my side A equals 26. So this is a rough estimate of what my triangle looks like. And I always think that's just that's as much fun, if not more, than doing this part. Okay, so we have a pair angle side, so that's what we'll start with. And then we have side B here, so we're going to go for angle B. So the sine of angle B divided by the length of side B has to equal the sine of angle A divided by length A, 26. Multiplying the 15 up, I get sine of B is equal to 15 times the sine of 106. I'm going to put degrees there, just a reminder to myself, make sure my calculator's in the right mode, divided by 26. See, I think I wrote that right. And then finally, we do the sine inverse or the arc sine. So B is equal to the arc sine of that fraction. And then remember, the arc sine only gives us acute angles. I'm at the moment going for angle B, which is right here, angle beta. And it's got to be an acute angle. At least it looks like it's an acute angle from this. How else do I know it's an acute angle? Well, since there's a sum of 180 degrees inside the triangle, then the angle C plus angle B plus my 106 has to add up to 180. And if I take 106 away from 180, I'm going to get a number less than 90, which means these two angles are acute. And even if they have to be, each of them have to be acute. So my picture shows they're acute. This idea about some of the interior angles of a triangle says they also have to be acute. And so the arc sine is going to give me an acute angle, which means it's the right angle if I type my numbers in right. So something to think about. Okay, so calculator time. And let's get a new version. Let's see, isn't there a refresh button somewhere? I guess it's that. Okay, so we want, this is angle B, I'm going to call it capital B, equals the arc sine of, and what were my numbers? They were 15. Oops, I put the 15 times the sine of 106. Make sure we're in degree mode in a minute. Divided by 26. Make sure I type that right. 15 times the sine of 106 over 26. That looks right. And then am I in degree mode? I'm not. And so I get B should be about 33. And again, let's think about that for a sec. When I was in radian mode, I'm getting negative 0.04 for the angle. What? Okay, so, I mean, you can have negative angles, but if you look at my picture, negative 0.4 degrees. Now my picture ain't perfect, but it's definitely bigger than 0.4 degrees. So that was an indication that I had screwed up my mode. 33.68. What does this say? Enter 2, how many decimal places? Doesn't say, which means I'm going to use more than 2. So how about 6814, 33.6814? So this is about 33.6814. Double check one more time. Yep, seems reasonable. Okay, picture-wise, does that seem okay? Yeah, I'd buy that that's about 33 degrees if I drew 15, 26, and 106 degrees correctly. And I don't think I'm too far off there. All right, what should we do next? How about angle C? Now, we could use the law of sines. No, we don't have enough information to use the law of sines to get angle C, because we would need side C, which we don't have yet. But we do have 2 angles in this triangle, so we can find the third angle. And rather than use this rounded version, I'm going to use the full accuracy of my computer, my software. And even on a handheld calculator, you can access the previous answer. So then on this calculator or a handheld, I would take 180 minus that 106, and then minus this previous answer here. So you could use the previous answer button on your calculator, or in this calculator, I just say, hey, I called it B. And so then I don't have to worry about rounding an intermediate step, and that's important with these problems because we use one number to get another, to get another, to get another, and that rounding error can build up dramatically. Like building a bridge from 2 different sides and then finding when you get to the middle, they don't meet. Oops. So we'll call this one 40.3186. So angle C is about 40.3186. And I got that by taking 180 degrees minus that 106 degrees minus my angle B. All right, let's see. And yeah, this angle looks a little bit bigger than that angle right there to me. 34-ish versus 40. I'll buy that. All right, next, to find side C here, we'll use the law of sines. So side C divided by the sine of angle C, which I'm just going to call C for now, because I'm not going to worry about that rounding. I'm going to use my calculator, is equal to, and then we always go back to the best information we had, which was in the beginning, not rounded information if possible. So then I'm going to take my 26 divided by the sine of 106 degrees. So side C should be equal to 26 times the sine of angle C all over the sine of 106. And sometimes like my side C and my angle C look similar. So to make that a capital, I usually put little marks there to make sure I don't accidentally grab the wrong number. So that's my version of capital C. All right, let's go to our calculator. And let's see, I should name this so I can use it again. C equals, or on a handheld calculator, you just go previous answer. So I've got my length C should be 26. No, I didn't get that right. Let's see. Yeah, did get it right. 26 times the sine of angle C. So 26 times the sine, and on my handheld, I would just do previous answer. On this, I do my capital C divided by the sine of 106. And make sure we're in the right mode. We should be, because we're on that same problem what we checked earlier. Yep. So I get 17.5009. So we think this is about 17.5009. So over here, this right here, 17.5009. And I realized I probably didn't draw my picture quite right. I see a flaw in my initial thought. So I'm going to try to redraw it. All right, so those are the numbers I got. Seems reasonable, but I don't know if my picture is. So I'm going to try one more time to redraw that, because how else can I check my work? So let's see, to do that before, so I'm just going to come up here. I think I can squeeze it in, draw my baseline. And then I'm going to say this is angle A. So that right there would be 90 degrees, and I want to go 106. So I think that's going to be around over here-ish. And then if this is angle A here, then side A is going to be somewhere over there. And usually we put angle B here and angle C up there. So this would be side B over here. So this right here is my B equals 15. And so then I have to estimate 15 on there. And I'm just going to say, let's break this into 3 chunks like that. Those aren't very equal chunks. Let's see, that would be about the middle. So a third maybe. So up to there is my 15. And when I just realized when I drew this line earlier, I was thinking about this being 26, but I need this to be 26 right there. All right, so I have to make my best guess, and a ruler is a way better way to do this on a piece of paper. It's much harder on my virtual screen. Pick a different color. So that would be, oops, I wanted a different color, please. And I'll record another video on how to do this on geometry software to make an accurate picture. So let's see, 15 would be there. And I want this to be like what, 26. So 26 is not quite twice as long. So that's going to come out, oh, and we have some angle estimates, don't we? We think this angle right here is supposed to be 40 degrees. So let's see, a right angle would be up here. 45 degrees would be down here. So I think 40 is going to be like that. There, maybe. Let's try to use this. This is, so I'm saying this is 5, 10, 15. So 5, 10, 15, 20. That looks like it's about 25 if this is about 15. So that's close enough. So I think this is about 26 there. And this side down here looks bigger than 15, but smaller than 26. So would we buy that's about 17? Yeah, not too bad. I'm thinking this is about 33 degrees, and I'm thinking this is about 40 degrees, or this is really like 34 maybe, and that's 40. This one was 106. Yeah, I'll buy that. These numbers seem reasonable. Nothing's way off. So we think we have answers from the law of sines. And again, you want to be able to verify yourself, and there's only 2 ways to do that, really. One is to try and sketch it out. If you have a protractor, that's great. And 2 is to just revisit all the calculations, see if you did it right. So we believe we have angle B, angle C, a little subtraction, and another law of sines, side length C there.